A programmer is deciding between using a linear or binary search to find a target value in a sorted list. Which of the following is true? A says in all cases, a binary search of a sorted list requires fewer comparisons than a linear search. This is incorrect because a binary search splits the list in half to determine which half the target value will be in the sorted list by seeing if the target value is greater than or less than or equal to the middle value of the list, and then it does the same thing with the half of the list that the target value should be in. So the binary search keeps splitting a list in half over and over again until it finds the target element, while a linear search just simply goes through every single element from the first element to the last to find the target element. So that means in cases where the target element is the first element in the list, the linear search will take much fewer comparisons than a binary search will. For example, if we have a sorted list of 1, 2, 3, 4, and 5, and the target we want to find is the value 1, in a linear search, the search just goes from the first element till the last and just checks whether the element is equal to the target value. So in a linear search, it'll just start at 1, see that 1 is the target value, and just return that first value. So a linear search will only take one comparison, while a binary search will go to the middle element, see if the target element is less than or equal to or greater than the target element, the middle element. So this means the target element in this case is 1. So the binary search will compare that with 3 and determine that the target value has to be in the first half of the list. So then in the first half of the list, it will then have to split the list again and then compare whether it is in the first half of the list or the second half of that half of the list. So a binary search will take more comparisons than a simple linear search in the case that the first element is the target element. So in all cases, a binary search does not require fewer comparisons than a linear search. B says generally the advantage of using a binary search over a linear search increases as the size of the list increases. This is true. As the list increases, the binary search rules out more elements every time it splits the list in half, because splitting the list in half will get rid of the half of the list that does not need to be checked, because the target element must be in the other half of the list. So a binary search, as the list gets bigger and bigger, rules out more elements, meaning less elements have to be checked every time. So as the list gets larger and larger, the binary search becomes more advantageous than using a linear search. C says a linear search will generally run faster than a binary search because a linear search requires fewer lines of code to implement. So just because linear search requires fewer lines of code to implement doesn't mean that the linear search is faster. A piece of code with less lines does not necessitate that that code runs faster. The length of code does not have anything to do with the speed at which it runs. D says using a linear search is preferable to using a binary search if there's a chance that the target may not be found in the list. In this case, using a binary search would be much better, because if a target is not found in the list, then every time the binary search halves the list in half, it rules out elements to not check. So that means a linear search would have to check through every single element in the list, while a binary search would not have to check through every single list until if it is finding a target that may not be found in the list. So the binary search is much more efficient since it doesn't have to check every element. So that means B is the correct answer. The binary search is more advantageous as the list increases in size.